Hi and welcome to Data Coder. In this particular video, I am going to discuss some more important concepts from SDTM implementation guide for beginners. So in the first video, I have discussed some important concept from implementation guide, and I have discussed it from very beginning of this document. So there we have discussed the fundamentals of SDTM, then we have discussed the observations and variables, datasets and domains, special purpose datasets, then the general observation class, the SDTM standard domain models, how to create a new domain, SDTM variables allowed in SDTM implementation guide. We have also discussed submitting data in a standard format. So we have also discussed the a table of HTTM submission dataset definition metadata, and today we are going to discuss what is a primary keys. So the primary keys in the dataset defines the uniqueness of the record within the dataset, and it may define a record sort order as well in the dataset. So this gives the reviewer a idea how the dataset is structured and what is the unique records for the datasets. So here in this example, if you see, those are the some variables mentioned as a primary keys, and the sponsor always modify it or add something or remove something according to the business need to get the primary keys. So here in the primary keys we have we have two keys. One is the natural key, another is surrogate key. So the natural key is something which is present in the data set. So the natural key are the variables which are present already in the data set, and we take the data set variables or the natural key, and we create a primary key sequence. And next is the surrogate key. So the surrogate key is something which is derived, which we generate. So for example, this sequence variable, okay, in any data set there will be a sequence variable. It's like a sequence or cm sequence or lb sequence. So the sequence variable we create by taking the primary keys, and we generate the numbers. We generate the unique numbers for each record. Sometimes the surrogate key or the sequence is also used in the primary keys along with the natural key. Okay, sometimes we put the sequence also in the primary keys. So it's all according to the business requirement or business need. So but we can do that. So the next concept what we'll see is the here in the assumption of domain models. So you can go through these general assumptions for all domains. So the review, study data tabulation and implementation guide, relationship to analysis dataset, additional timing variable, and order of the variable. So order of the variable is important. So in the dataset, when we keep the variable, the order of variables in the CDS domain models has been chosen to facilitate the review of the models and application of the models. Variables for the three general observation class must be ordered with identifier first. So the identifier variable should be kept first, then followed by the topic, qualifier, and timing variables. So this is the order we should follow while creating a SDTM data set. Next important concept is CDS core variables. Okay, so previously we have discussed the classifications of variable based on their roles, and here we'll see the classification of variables based on core. So the concept of core variable is used both as a measure of compliance and to provide general guidance to sponsors. So three categories of variables are specified in core column in the domain model. First is the required, then the expected, and then permissible. First we will see what are the required variable. A required variable is any variable that is basic to the identification of the data record, that is essentially key variables, and a topic essential key variables and a topic variable, or is necessary to make the record meaningful. So required variables must always be included in the data set and cannot be null for any record. So the required variable should be present in the data set and the value for this variable cannot be null. So there should not be any missing value for required variable. Next is the expected. Next is the expected variable. The expected variables is any variable necessary to make a record useful in the context of a specific domain. Expected variable may contain some null values. So here the variable should be included, but it's allowed to have some missing values. But in most cases, will not contain null values for every record. So when no data has been collected for an expected variable, however, a null column must be still included in the data set, and a comment must be included in the defined.xml to state that data was not collected. So if no data is collected for a expected variable, still the variable should be included in the data set, and we can mention these notes in the defined.xml. Next is a permissible variable. This permissible variable should be used in a domain as appropriate when collected or derived, except where restricted by specific domain assumptions. Any SDTM timing or identifier variables and any qualifier variables from some general observation class are permissible for use in a domain based on the general observation class. The sponsor can decide whether a permissible variable should be included in the column when all the variables for that variable are null. So the sponsor does not have the discretion to exclude permissible variables when they contain data. So when the permissible variable is something, the variable either we can keep or we can remove, and it can contain null data. So when there is a data, we should keep it, or if it's there are no data, then we can probably if the sponsor want, we can remove that. So next is guidance on a dataset naming. So how to name a SDTM dataset? So these two character we use to name the dataset, and the name should be dm.xpt. The dataset name.xpt. So whatever the dataset we are creating, the dataset name and the xpt suffix should be added to it, and for supplementary domain sub prefix should be there, and for relationship dataset relex should be there. And if we are creating a new custom domain, okay, then we should add this prefix of either x, y, or g. Okay, we can add to this custom domains. So you can go through in details how to create a custom domain and what are the rules and regulations we should follow while creating a custom domain. Next is splitting domains. So sponsor may choose to split a domain of topically related information into physically separated data set. In such cases, one of two approaches should be implemented. So for the similar topic data, how the data is collected, if our topic variable is same, then we can choose to physically separate the data set, and while separating the data set we should follow these two rules. So either one of them we need to follow. So for a domain based on a general observation class, splitting should be according to the values in cat, or based on the category variable, which must not be null. So the category, based on the category and non-missing category values, we can split the data set. Or the finding about FA domains can be split either by category, or which is based on this, or we can split it based on this obj, FA obj variable. For example, for a CM related record in FA, we can create this FACM, and it should contain the data findings about CM record. Okay, so this is just an example, and the following rules must be added when splitting a domain into separate datasets to ensure they can be appended back into the domain dataset. The value of domain must be consistent across the separate datasets as it would have been if they had not been split. So the domain value has to be consistent across all the splitted datasets. Next is all variables that require a domain prefix must be use the value of domain as the prefix value. For example, for test city, location, or test, we should use the prefix. Okay, for example, like LB test city, or LB VS log, or LB test, or QS test, QS test city. Sequence must be unique within use subject ID for all records across all the splitted dataset. So if there are 1000 records for use subject ID across the separate dataset, all 1000 records needs unique values for sequence. When relationship dataset, example supplementary dataset, or this FA splitted dataset, or relate back to split parent domain, ID var should generally be what we use is sequence variable. But when ID var is used other than this sequence, for example like group ID, or real ID, ref ID, or SPID is used as ID var, then we should be careful, should be used to ensure that the parent record across the split data set have unique values for the variable specified in the ID var. So whatever the ID var variable we are mentioning, it has to be contain all the unique values, so that it will helpful to relate the children record to to the parent record. Next is permissible variables included in the split data set need not to be included in all split data sets. So you can go through in details, and the next one is split dataset names can be up to 4 characters in length. For example, if splitting by category, then the dataset names would be the domain name plus the 2 additional character. So if you are splitting this QS domain based on this QS cat variable, then it has to be QS and what is the category, QS36 QS36 for SF36. If the category is SF36, then the dataset what we can keep is QS36, and QS is the QS domain, 36 is the category. If splitting findings about by parent domain, then the dataset name would be the domain name plus the 2 character domain code describing the parent domain. For example, if FA domain we are splitting for CM records, we can keep it as a FACM. FA record, FA dataset, if we are splitting for A records, then we can keep FAA. Supplemental qualifier datasets for split domain would also be split. The nomenclature would include the additional 1 to 2 character used to identify the split dataset. For example, for this SF36 dataset, we have created this QS36 split domain. but for the supplementary it has to be sub QS36, and for FACM it's sub FACM, for FAA it's sub FAA. The value of R domain in the sub dataset would be the 2-character domain code, example QS or FA. Next is in RelReg, if a dataset level relationship is defined for a split findings about domain, then the R domain may contain the 4-character dataset name as shown in the following example. So here if we using that splitted domain into in the to relate with other dataset, then we need to use the same name how the dataset has been named. So if it's FACM, then the R domain should be FACM instead of CM. So these are the things, and you can go through in details to get it clear. So here is the example of splitting this questionnaire dataset. The example shown in the split QS domain data into 3 datasets: clinical global impression QACG, Cornell scale of depression in dementia QSCS, and this QSMM. Each dataset represent a subset of the QS domain data and has only one value for QS get. So here if you see, for this QS domain, first dataset is QSCG and the dataset name is QSCG.xpt. QSCG.xpt. So here we have the variable like study ID, domain, use subject ID, QS sequence, QS SPID, test city, test, and QS category. So here the QS category, it's unique, and the domain, in the domain we need to mention the parent domain name, that is QS. For the second dataset QSCSXPD, this is also splitted from the QS domain based on the categories, and here it's for the another category. And here also the domain name should be the parent domain, that is QS, from where it's splitted. And the third dataset is QSCS, QSMM, and the dataset name is QSMM.xpt. And here also it's splitted based on the category, and the domain name is QS. And in the similar way, the supplementary datasets are also mentioned. So this is QS sub QSCG, sub QSCS, sub QSMM. So this is the example how a dataset has been splitted based on category from the parent domain. Next is origin of metadata. So origin of metadata for variables. The origin column in the define.xml is used to indicate whether the data originated, from where the data is originated. Its purpose is to communicate to the reviewer whether data was collected on a CRF, and so that we can it's traceable to an annotated CRF, or if the data is derived, it's traceable to some derivation algorithm, or it's assigned by some subject process, then we can see the external evaluator. The SDTM IG defines the following control terms for specifying origin. So note that other values may be defined by the standards as well, but here we'll see only these categories. The first one is CRF. So the origin is CRF. That means the data is collected in a CRF, and we have annotated CRF for that. Next one is the EDT. When it's a EDT, that means the data is captured by some electronic data transfer. We receive the data by some electronic data transfer. So it's usually the external data like laboratory data or ECG data or the IVRS data what we get from vendor. Next is derived. So derived means the data are not directly collected on the CRA but are calculated by an algorithm or reproducible rule. So based on some rules or based on some algorithm, we are deriving a values which is depend upon other data values. So this algorithm is applied across all values and may refer other SDTM dataset. The derivation is assumed to be performed by the sponsor. This does not apply to derive lab test results performed directly by lab. So here some examples illustrating the distinction between collected and derived value included in the following. So a value derived by an ECRF system from other entered field has an origin of derived since the sponsor controls the derivation. Next is a value derived from collected data by the sponsor or a CRO working on their behalf has an origin of derived. So next, a value derived by an investigator and written entered on a CRF has an origin of CRF along with the reference rather than derived. So if the value is collected in CRF, then it should be CRF. If the value we are getting directly from the external data, then we should mention EDT. So if it's derived by the vendor, that's fine. We should not keep the origin as derived. We can keep it as a EDT. Next is assigned. Assigned means some value we are assigning, like the domain name or the test code. Okay, so a value that is determined by individual judgment by an evaluator other than the subject or investigator rather than collected as a part of the CRF or derived based on an algorithm. So these are the example, this decode, domain name, test cd, what we can keep the origin as assigned. Next is protocol, a value that is defined as a part of the trial design preparation. An example would be VS pose, like vital sign position, which may be specified only in the protocol and not appear on the CRF. If something is mentioned in the protocol and we are getting the value based on that, we are displaying the value based on that, based on protocol, then we can keep the derive as origin as protocol. So next is the term sponsor defined was used in earlier version of the SDTM implementation guide to advise the sponsor to supply the appropriate origin value in the metadata. The text sponsor defined was not intended to be used in the define.xml, and it's no longer used in SDTM 3.1.2 and later. So this is all about this video, and in the next video we are going to see some more concepts of SDTM implementation guide, which will help the beginners to start their career as a clinical SaaS programmer. So please go through the first video as well. If you have not gone through yet, then check the second video and subscribe to this channel for upcoming videos on this SDTM implementation guide and other SaaS related videos. And see you in the next video. Thank you.